Hello, welcome to this lesson of our study of vectors. Okay, so in this lesson, just go through the last points or last section about vector products. Okay, so this one we'll call it the cross product or vector product between two vectors. Okay, so if you have not subscribed to the channel, kindly subscribe so that you'll be able to support the channel as well. Like my content and also share them to other friends so that they can benefit from the content here. Alright, so let's start. Now the vector or cross product of two vectors. Okay, so the vector product or the cross product of two non-zero vectors. Okay, non-zero vectors A and B is denoted by A cross B. This is how you write it, and it's defined as A cross B is always equal to magnitude of A times magnitude of B sine of theta, then n cap where n cap is a unit vector which is perpendicular to both A and B. Theta is the angle between A and B, and theta falls within this range. Okay, so these are what you are supposed to know. Okay, so this is the definition, and these were the theta is between. Okay, and then this is n is the unit vector which is perpendicular to both A and B. Alright, so let's look at some basic observations. Okay, so A cross B is always a vector. That is one thing you should always know. The cross product of two vectors is always a vector, but the dot product or the scalar product of two vectors is always a scalar. I hope you get it. So just as we are going through, then you are supposed to, be recalling and stating the difference by yourself. So when A cross B equals 0, and both A and B is not equal to 0. Okay, here it's supposed to be they are not equal to 0. Then this implies that A and B are parallel or collinear to each other. That is, the theta between them is 0. But both A and B are not 0. I hope you get it. So now if theta is equal to pi over 2, which is 90, then it means that A cross B is actually equal to magnitude of A times magnitude of B, where sine of theta, sine 90 is 1. Okay, so this time theta is 90. So that is how come you get this. And now with cross product, this is how the angle is being calculated. Sine of the angle between them is always equal to the magnitude of A cross B, then over magnitude of A times magnitude of B. So you use this to find the angle between two vectors in terms of cross products. I hope you get this. So let's move ahead. Given both A and B, A to be this and B to be that, and A cross B is this is how you find it. So you pick the I, okay, then you cancel this part, then you take these ones, okay, then you find their how do you call it, determinants. Okay, you use determinant method, so you cross them like that, and the remaining elements in the, let me say, the bar, you use you find the determinant, then you multiply it to I, just like this one, like I've done here. Then the next term is, then you subtract, okay, minus, then you pick the J, sorry, then that one, so you go through it horizontally, that is cancelled, and then you go to vertical, you cancel that. So the remaining ones will be this one and this one. So that one, so you find the determinant and you multiply it to a J. Okay, and go to the last one, which is the K. You stand on this K, you go through it vertically and horizontal again, then you find the determinant of the remaining matrix, and that one is a plus in front. Okay, so the only part where you have negative is the in front will be the J component. Okay, I hope you get it. Then you know how to find the determinant of a matrix or a 2 by 2 matrix. So this side multiplied and minus this side multiplied. Okay, I hope you get this. So that is what I have here, I, then this J, then I have this one as well, which is a K. Okay, so let's go ahead and look at it in a different or a shortcut form. Okay, so if I have both A and B to be this, Then what will be my shortcut in finding A cross B? First of all, I start writing the whole of A, the elements in A. Okay, I will start here, start and stop there. Okay, so start and stop. So you start writing from A2, you start A2, then go to A3 like that. Okay, A3, then A1, then you come and end at A2. So you start from A2, that's the J component, and you end at the J component. You come to the second vector, you do same. You start from the J component, which is B2. You go, then you come and end at the J component. Then the next step you should do is this: you write them in how do you call the first one on top of the other. Okay, so like this, like I've arranged them here. You do that. Then you pick the first entry from the top. You multiply it to this side. Okay, and that will be A2 B3, then minus this and that. So you have that. Okay, then plus. So this time you don't subtract. So then this time plus. You do this and that like this. Then you subtract from this like that. Okay, then go to the next point. So that one 2 plus this. Okay, and that will be this minus this one. Okay, so for each time you attach their their respective directions. So the first one will be for I, second one will be for J, and that will be for K. So this one you don't need to do any determinant. So you just start writing from the second component. Like I said, if you think that you can't go by this method, just stick to the other one. That is more academically proved than this one. This one is just a shortcut. Okay, so when you pick examples, work in both this one and the other one so that you know which one is faster than the other. Okay, so application of cross product. So we apply cross product in the area of a triangle. So with the area of a triangle, realize that if I represent the two sides of a triangle, okay, let's say I represent these sides, this side and this side, okay, by two vectors A and B, then the angle between them is theta. Okay, now I want to find the whole area of the triangle. Then I'm supposed to find the height. Okay, you know that the area of a triangle includes a height. So the area is actually this half times the base times height, and the base here is the length of B, because the whole of this base is B, is the vector B. So the length of the base will be the length of B. Okay, now that will be the area. Okay, but I don't know the height, but we know the vectors on both sides of the triangle. Now we know that sine of theta from the Pythagoras theorem, sine of theta here will be equal to h. Okay, this I'm talking about, this sine of theta will be equal to h over magnitude of a, using the triangle, this triangle where a is going this way and this is h. Okay, and this is theta. Now the length of that will be magnitude of a. So sine of theta will be equal to opposite over hypotenuse, which is magnitude of a, h over the magnitude of a rather. So now with that we have that. So it means we can make h the subject and put h in the area formula. So h is simply magnitude of a sine theta. And come and put it there. You get a being equal to half magnitude of b times magnitude of a sine theta. But these two can be written as magnitude of a magnitude of b sine theta. This is the cross product of a and b. Okay, I hope you get it. So but this whole thing will give me a distance, a length. So it means I can represent the whole of this here, the whole of this, by a cross b. But then mind you, you are calculating for magnitude, a value. We are not calculating for a vector. So all that we need to do is just find the magnitude of a cross b, then multiply it by half, and that will be the area of the triangle. I hope you get it. So you can put it in mind when the two of them are represented on the size of the two sides of the triangle. So they should be represented on the size of a triangle, not just any vectors like that. Okay, and the next one is area of a parallelogram. So the parallelogram, the area is given by the base times the height. Okay, so this is the area. Okay, that is the area for us. Okay, this one. But you know that AB, from A to B, the distance will simply be magnitude of B. Okay, so that one you don't have any problem. That is when you have two vectors represented on the two sides of a parallelogram, or two adjacent sides of a parallelogram. Okay, and the angle between them is theta. So what you can do is that one too, you have to find your h. Okay, so we go through the same process like we did for the triangle, and this is how h looks like. Okay, so I'll come and put h back in the main equation of the area, which is this. So I'll put it here. Now when I put it, I'm getting a magnitude of a times magnitude of b sine theta. And this, if you remember, we said that a cross b is actually equal to magnitude of a magnitude of b sine theta. Okay, so that is a cross b. Now we are looking for area, which will be a distance or magnitude. Let me put it that way. Then it means you have to actually find a magnitude of a cross b, and that will be, what do you call it, the area of a parallelogram using cross products. Okay, so that will be for this lesson. In our next discussion, we'll take some examples and walk through them like we did for the dot products. Okay, thank you, and don't forget to subscribe to the channel. All right, see